Hello friends. So now we'll be seeing with our second algorithm, that is your optimal page replacement algorithm. So here in optimal page replacement algorithm, what we are doing is we will try to replace the page which is not used long in the mention time. Okay, long in the mention time, just we will try to understand that while we are seeing this problem, right? So here, let me just write the frames. Okay, this is frame number one, two, and three. Initially, there is no any page in this frames. Okay, so if you see here, these are the requests by the CPU. These are the page requests by the CPU. The initially it is requesting for page number 7. Is it there in this main memory? No. So I can call this as page fault. Okay. And I will be replacing. So this is quite easy that initial 7, sorry, 3 frames, I can easily write it as all as fault. 7, 0, and 1. I hope you got to know that how I have written. First frame, it is not present, fault, so write 7. Second frame is it is requesting for 0, 0 is not present over here. So we will write it as page fault and replace 0 in the second frame. And third page is requested as 1. 1 was not present in the main memory. So I will write it as fault and 7, 0, and 1 is done. The next is 2. This is where exactly your optimal page replacement algorithm starts because there is no free slots available. Okay, so now 2, where 2 should be replaced. If I am working on first in, first out, so 7 was replaced and 2 was written. Sorry, 2 was taking the place of 7 over there. But in optimal page replacement algorithm, which is the frame I want to insert, it is 2. After this 2, we have to check the future pages what are coming. Right? What are the future pages coming? It is 0304230310120. So check here. Where is 0? It is here. Okay, it is very recently in use. Okay, so we will not replace this. Okay, can we find 1? Yes, we are finding 1 over here. Okay, which is not used, it is 7. So definitely I will replace 7 because it is nowhere used in future for me, right? So 2 is replaced. So definitely see, 2 was not present, so I will first write it as it is also fault, but 7 is replaced by 2, correct? So 2 is done now. Next page which is requested is what? 0. Is 0 present? Yes. If 0 is present, I will write it as what? Hit. So 0, 1, and 2 is there. Which is next 3. Is 3 present over there? No. So I will write it as what? Page fault. If it is a page fault, then which one should be replaced? Is it 1, 0, or 2? So check here. After 3, what are the requests you are finding in future? 0, 4, 2, 3, so on, right? So 0, yes, it is recently. Next turn is for 0, which is not used very recently. 0, yes, it is in future. I am using it very recently. In future, I am using it. 2, I am recently using in future. 0 and 2, but 1 which is used last. Okay, so this is 1 which is used very after few requests. Okay, but 0 and 2 I will not, I will retain. Okay, 1 I will replace. Why I will replace 1? Because after 3, 0 and 2 are recently, what you can say, sorry, very in very near future I am using this 0 and 2, so I will retain it. And 1 in very far future I am using 1, so I will replace that 1 with 3. Okay, so 3 is replaced in the place of 2. Hope so you are getting how this optimal replace page replacement algorithm is working, something different from your first in first out. So 3 is done. 0, yes, 0 is already present, so I will term it as hit. 4, is it there? No, so I will term it as fault. So after 4, you can see 2, 3, 0, right? So 2 and 3 are used, 0 is late used. So I will replace 0 and I will write here 4. Correct. So after 4, which is asked 2, 2 is present, so I will mark it as hit. And after 2, 3 is present, 3 is asked, 3 is also present, so I will also mark this as hit. So after that 0 is present, 0 we can't find it, so I'll mark it as fault. So here also you can mark it as fault. Instead of star, I will mark it as fault. So 3, yes, sorry, 0 is not there, so I will mark it as fault. So instead of 0, which one I should replace? 3 is where in near future I am using it. I can go with 2, 2 in near future I am using it, 4 I am not using. So I will replace 4 with 0, correct? Fine. So after 0, which is the next page request, 3, yes, 3 is present, so I will mark it as hit. And after that 1 is 1 present, 1 is not present, so I will mark it as what? Fault. But instead of where I should place this 1, if you see here, 2 is used very shortly, 0 is also used, 3 is not used. So instead of 3, I can mark here 1. Okay. So after 1, which is the request, 2. So definitely it is hit because 2 is already present in main memory. And after that, 0. 0 is also present. So this is also again a hit. Okay. So this is how your optimal page replacement algorithm works. If you can just see here, in the previous algorithm, there were, I think, so only 2 hits, right? But if you see here, 1 hit, 2 hit, 3, 4, 5, 6, and 7. If you see this, the number of page miss is reduced compared to your what? Compared to your previous algorithm, that is first in, first out. See, in this first in, first out, there were page hits only 3. But if you see in this algorithm, how many page hits are there? 1, 2, 3, 4, 5, 6, and 7. So that is how optimal page replacement acts or else behaves in a better way than your first in first out page replacement algorithm. So here also they may ask you to calculate the hit ratio and miss ratio. The same formula you can use, that is number of hits divided by number of references multiplied by 100. And the miss rate is also same, number of page faults divided by number of your reference strings multiplied by 100. So that is how you can calculate your page ratio, that is hit ratio and miss ratio. Okay, so this is how you will be doing for your page replacement algorithm. And sometimes they may ask you for 4 frames. Do this problem for 4 frames. At that time, instead of 3 frames, you can just see here, we have taken here 3 frames, right? So you can take one more as fourth frame and you can calculate it. That is 701, and here you can come it as 2. Okay, that is how the algorithm will change for 4 frames. Okay, at that time, instead of using 3 frames, you can go for 4 frames. Okay, so that's it for optimal page replacement algorithm. So we will be ending this, and in the next coming video, we will be seeing the last algorithm, that is your least recently used. Okay, so fine then. I will conclude this video. So I will be shortly sharing you the next video. Thank you. Thank you very much.